Welcome back. This is Paolo, your host. This is Conversations in Artificial Intelligence. And today we're going to go and talk about restaurants. Oh, I'm just kidding. Today we have a very, very interesting individual, a veteran of artificial intelligence in Silicon Valley. And he's going to talk about how companies use artificial intelligence, what are the difficulties for managers to understand what the value of artificial intelligence is, and how, in principle, companies should use artificial intelligence to produce value. By the same time, how they should manage their data scientist teams and their innovation teams so that they achieve the best results possible. So with me today, we have Charles Martin, who is the founder of Calculation Consulting, and he is a consultant scientist. He has worked for a long number of companies here in Silicon Valley, from Hard Rock, who was then acquired by Google, to companies like eBay, BlackRock, GoDaddy, and many, many, many more. So I cannot remember all of them. He's really a veteran here in Silicon Valley. So Charles, how are you today?
Great. Nice to be on board. I'm looking forward to it.
Charles, the way I met you is basically, I was listening to a number of podcasts. I heard you the first time and I said, this guy's very interesting. He has a very interesting way of talking. And then I heard you another time and I said, I must reach out to this guy. So tell us a little bit, how did you end up in artificial intelligence and why, you didn't become a comedian? Because
I will. I used to work in theoretical chemistry and physics. And I did and I was a gymnast, so I used to do gymnastics. And when you do gymnastics, you tell your brain tells your body to do something and it does something else. And you try to flip and you twist. And I didn't want to twist, I want to flip. What's going on? And you go crazy trying to figure out how to make yourself do these very complicated skills. And you realize that your brain is doing things that you don't realize that it's doing. And after years of this, I realized that maybe this would be something very interesting from a scientific perspective to try to get a better handle on neuroscience and what your brain does. And in those days, AI and neural networks was very bespoke, and a lot of the work was done in theoretical physics and theoretical chemistry. In fact, some of the early neural network models were invented by Jack Cowan, who was in the 60s, who's a good friend of my advisor in Chicago. So I decided to do my postdoc. I was an NSF postdoc in theoretical chemistry and physics. And I did my postdoc in a group that was doing basically theoretical physics of neural networks and learning. And that's how I got into AI.
Oh, that's so you basically, you came in from really the science of it, the research and the academia.
I mean, look, neural networks are chemical models of neurons. They were invented by theoretical chemists. They were invented by guys like John Hopfield, or you look at Christopher Longet-Huggins, who set up the School of Machine Learning in London, where Geoff Hinton did his PhD. He was a University of Chicago guy, and he was a theoretical chemist before he did machine learning and AI. So it's always been, neural networks has always been part of theoretical chemistry and physics. So it's just our stuff. And now everybody's doing it, right? It's everywhere. But we were doing it in the 80s and the 90s.
So how did you convince the managers of the time to hire you then?
So I worked with a startup, which was started by my graduate advisor's son-in-law. And it was a search engine doing personalized search. And I invented some of the first algorithms for things like learn-to-rank systems using machine learning and transductive learning systems. This was back in the late 90s, early 2000s. And after that, I went to work with George White. Now, there's a movie on Netflix called General Magic, but my friend George White, who was one of the founders of Xerox PARC, and he was an AI guy. And they started a company called General Magic, and it was one of the great failures of Silicon Valley. But very famous company in the 90s, 80s and 90s, the late 90s. And George was an AI guy. And he was doing things like, they invented things. Like they invented the mouse. His team at Xerox PARC invented the Windows operating system. They invented the mouse. They invented speech recognition. So, and he ran the AI group at Stanford. So he's a very famous guy back in then. And he was a mentor of mine in my early career. So I've been involved in AI for a very, very long time. And you just have to find companies, early companies were like eBay. eBay had an R&D division, and eBay was doing sophisticated machine learning, 10, 15 years ago. People don't think of it. They always think about Google or Yahoo. eBay is like a small country, the size of their economy. So they have a big operation, and we did a lot of work there. And a lot of the work I did at eBay, the research I did at eBay ended up in Aardvark. Like what I learned at eBay, I was able to bring to Aardvark, and the Aardvark, of course, was acquired by Google. So, we were doing things like machine learning and AI and learn to rank. We were doing neural networks for learn to rank 10 years ago. It's all Google and Facebook talk about, and they've put, hundreds of millions of dollars into it. So, the scale now is just tremendous. What you can do is just phenomenal.
So, but here is the thing. Everybody talks about it today, but how well people outside of these 4 or 5 tech giants can understand the value of artificial intelligence, really can incorporate it in their businesses. That, to me, remains a little bit of a question.
It's just like the internet was in 1995. You're either going to do it or you're going to go out of business. I live in Silicon Valley. So I like to tell people Silicon Valley, we're west of the Rocky Mountains. Silicon Valley, Seattle, this part of the world, basically we're at war with the rest of the country. We're in economic war. And people out here don't think about, I'm going to add value to a company. They think, I'm going to take over entire industries. We're just going to put you out of business. You look at Amazon. Amazon has successfully decimated the retail industry. They've done it using AI. Amazon was using neural networks, exploring this technology 20 years ago when they started. The Amazon recommender system, and that is an AI system. That's the basis of how they're able to keep their margins so low. Look, if you're a company right now, you've got to realize there's probably some startup in Silicon Valley in some garage somewhere, or some WeWork space, thinking about how they can do what you do at half your margin using AI. And there's just no way you're going to be able to compete against it. So you've got to get on board now and start thinking, how do we start integrating this technology? How do we start doing things with this before and it's companies think because you're big that you're somehow defensible, but it's death by 1,000 cuts. A Valley comes in and just looks at all your product lines and begins cutting them off one by one. And that's what's going to happen. Look at Uber. They took over the world taxi industry. Airbnb, they took over the world. They're taking over the world hotel industry. These are algorithm companies. What does Uber do? It has an algorithm that matches you to a car. That's, is it AI? It's algorithmic. That's where the world is going.
A lot of people still believe that artificial intelligence is the next thing in IT, and it's like IT.
Do you know the TV show, the very popular show, Big Bang Theory? Look, there are 3 types of techies. There's Howard, there's Leonard, and there's Sheldon. And Howard is sort of the engineer. He went to MIT. He's got a master's degree. He's very good. He has a certain way of doing things. And then there's Leonard, and Leonard is sort of the applied data scientist. He has the beautiful girlfriend. He's sort of the most normal of the group. And then there's Sheldon, and Sheldon's the theoretical physicist, and he's, off the charts weird. I always like to tell people there are different kinds of techies. And so far, industry has been dominated by the IT world. So these are the IT guys who came in, in the late 90s. AI is not IT.
Why is not IT, and why is it different technology?
AI is fundamentally a discovery technology. It's a research technology, and IT is more about delivery. So you have to realize there's a huge difference between delivering products and building them and discovery. And that's why we call it data science, because it's a science. So the best example I like to give people is think about a restaurant. What is a restaurant good at? You go to a restaurant, what are they good at? Okay, if you run a restaurant, what do? You take the order, you cook the food, give them the check, take the money, you clean the table. Behind the scenes, what happens? You have to order, what do you do when you run operationally a restaurant? You have to order the chicken and the potatoes, from whoever your supplier is. You've got to hire staff and train them. You got to have people to clean the dishes. You have to follow the regulations of the city. All of these things are part of running. You run advertising campaigns to get people into the restaurant. All of these things are operations. You deliver food to people. Maybe even deliver now, you have delivery services. You give a delivery and you deliver food right to your door. What about the actual food itself? Where's the food come from? What do you mean? Like, who's the chef that makes the food? If you're starting like a sushi restaurant or a Thai restaurant, everybody has the same food. You get pad Thai, you get your rainbow roll, you get your curry chicken, but it's all the same stuff. But if you think about a real restaurant, like a restaurant that you really want to go to, they have a chef. Somebody had to sit down and create these unique recipes. That's what AI is. AI is like being a chef. You have to discover what's going to work. And that process is totally different than all the operations that you would do. And so if you start a restaurant, and if you want to do something which is really unique and you want to have people, you want to have some unique position where you don't have competitors who are just going to be nipping at you all the time, you have to have some unique value proposition. And AI is going to help you discover that. But that's not something that is just going to be put into a pipeline and you deliver. I mean, you have to figure it out. The challenge that companies have is creating this innovation pipeline. How do you do innovation? And AI is fundamentally about innovation. It's an innovation technology. That's what makes this so hard and why companies are having so much trouble really figuring out, getting their hands around this technology.
Let's say a normal company is looking at innovating, leveraging artificial intelligence. And they have some vague ideas of what can be done, at least from a business perspective, but they have a full understanding of how to go about it. When do you think they should outsource and ask the help of people that have been in the industry, or when they should hire their own team?
They're going to hire their own team, and they're not going to find anyone in a leadership position. Because there's no one in these organizations. If you hire a team, you're going to hire a bunch of AI people and you're going to put them under a guy who maybe, was a Ruby on Rails expert, or maybe someone who works, with solar or some related technology. But you're going to have a lot of trouble finding someone in a leadership position who really understands this technology. And that's the challenge. There are lots and lots of data scientists who have like 1 or 2 years of experience now. Those people are everywhere. People going to data boot camps, people coming out of school. Yeah, there's huge numbers of them. But how many people are you going to find who have 10 years of experience and have deployed AI technology in companies like eBay or Google or Amazon? They just don't exist. So you've got a real problem. And if you look at the offerings now, for a while, Amazon was trying to offer AI services like object detection and, automated machine learning. And, Google and Amazon and Microsoft have these cloud services. But Amazon now is setting up a machine learning consultancy where they do projects for companies because they realize people can't take these Amazon services and use them to build anything. Like they need more help. These off-the-shelf services Amazon has been providing is more like a lead gen to get people to come in and I know this because they tried to hire me. So, and Amazon has the same problem. They try to hire someone for their machine learning consultancy. Who do they hire to run the consultancy? I mean, how do you interview these people? They don't even know how to interview them. So it's a real problem finding people in industry who have that experience and who really know how to build these things. And the people who really know how to do it, really the young people who really are good at it, they're out here in Silicon Valley starting companies. I mean, if I were 30 years old or 25, I'd probably go do that. Go raise money, venture money, because when you're if you want to sleep 4 hours a night, that's what you do. But listen, even Google, I work with guys at Google. They didn't know this stuff. I worked with the top guys at Google when I was at Aardvark. Google acquired this technology. They acquired Aardvark. They acquired Applied Semantics. They acquired Google DeepMind. And they transformed their whole company. They had to bring these people in, and they the magic of Google is Jeff Dean, when he was in grad school, worked on neural networks, or maybe undergrad. He knew something about it, but it's taken them a long time to transform. So that's the real challenge that companies have is the leadership, finding someone who can lead these projects.
But then if, at scale, this technology has emerged in the last few years. I mean, it's been around for a while in the form of predictive analytics. There was a part of it. It's been around in some of the Silicon Valley companies, but it's booming now. So how do you envision that companies can solve this problem of the lack of experience?
Well, they've been acquiring, right? They've been acquiring startups. That's how they find leadership. And in Silicon Valley, that's how you do it. You find leadership, but you acquire people. That's how they do it. You find people who start an AI company and you buy them. When I was at GoDaddy, they had acquired a machine learning company. And that was the group we were working with. They acquire them. You can go and try to hire them out of companies, but you have to pay them. You have to pay them a lot of money. Well, another problem you're going to find is that you're going to try to hire someone, and I have this problem. You're going to try to hire someone in Silicon Valley who has experience, right? This is an expensive place to be. I live in the most expensive place in the world, maybe next to, probably more expensive than London or Tokyo, San Francisco. So you got to pay them. Are you going to be, and you're going to have a problem if you bring in a senior AI leader and you find out that their salary is twice the salary of your engineering director. That's a problem. And you're going to have to convince them to, and if they're older and they live in Silicon Valley, you're going to have to convince them to move. Well, they have family. So, it's not that these people don't exist, but you've got to find them, hire them, pay them, and move them out. Do you want to move to New York and make $500,000 a year? No, I don't want to move to New York. I live here. So these are real issues that you have to face. You're going to have to give someone, a real package. If you want to hire them, you're going to have to give them a real package, which is attractive. Or you're going to, we do consulting. We try to train people. The challenge in Silicon Valley is always you want to find someone who's really, really talented, but is willing to work below their market cost, below their market price. That's what the Valley is all about. You find these young people, these kids out of Stanford or UC Berkeley who are super, super sharp, but haven't been in the market long enough to really demand crazy salaries. So you got to find them. It's a real challenge.
Even if you put the right person, this person has still to interface with all the business elements of the companies. I mean, there is a communication that has to happen there, but there is also, an ability of the entire company to take this one piece of innovation, take it to either save money, make money, or improve somehow processes in a way or another. So, what have you seen, or what is your experience, or your ins on that particular?
Question. So there are sort of two ways people think about this. I think a lot of people think that AI and data science, it's kind of like you're going on a treasure hunt. We're going to Alaska. We just had a big conference in Alaska, the big data science conference in Alaska. Why does Alaska exist? Why do people go there? Gold. There's gold in Alaska. So, people think that data science is like you're going and hunting for gold. And you're going to hire a bunch of data scientists and you're going to give them a bunch of data and you're going to lock them in a room by themselves. And they're going to come back 3 months from now and give you some magic. And they're going to find gold. Maybe, half the time that might work, actually. Being a good manager isn't always about knowing the technology. It's just sometimes just being a good person and knowing how to deal with people. And if you're smart and you know how to deal with people, you might be able to hire some young people or, junior, mid-level people, put them in a room, give them a bunch of stuff, and they might come up with something. But that's a high-risk endeavor, right? It's high risk because they might get, you're going to give them a lot of money and resources. You got to put them away by themselves. They're going to have to work by themselves with really no senior oversight. And you're going to have to hope that they come out with some chunk of gold, some nugget of gold that you can then sell. So a lot of companies are doing that. And it's kind of like a 50-50 shot. I have had projects like this where we came in, demand media was a good idea. They came in, they gave me some data. I flew out to LA, got some data, came back with them with an algorithm that increased their revenue by 500%. They were the first $1 billion IPO since Google, all using machine learning. So that was like, I basically hit a home run. But I have a better, what I really propose to people, that's really a very high risk endeavor. If you want to reduce your risk and you want to really have an innovation pipeline, what you have to do is think like a lean startup. And you have to ask yourself, how can I create some technology that I can move quickly into my production environment without too much overhead. And I can run an experiment to see whether we can use this solution to make money, save money, improve something. How can I run the experiment as quickly as possible? And you want to think to yourself, maybe I have 6 months to do this. I want to run 6 experiments. I want to run 1 experiment every month to figure out what's going to work. That's how Aardvark was done. Every month they had a new product every month for 6 months until they settled on the actual product. So that's the lean startup. You have this ideation process, but it goes quickly. You can test it quickly. You have metrics that you can test. You can get feedback and you can decide, do I want to use this or do I want to kill it and do something else? Those are the most successful projects because you can iterate quickly. You can get immediate feedback. And if you get a win, now you have a win. Now, every company is just a bunch of people, and every project starts with just a few people, and those people have to get an easy win. You have to be able to give them a win so your AI person can go to the manager and say, here, I have an easy win for you. Take it to your bean counters and tell them that it works, give us more money. That's what you want to do.
However, in my personal experience, it's not easy to do. Let me give you a few things that I have seen. Number one, the data are siloed, and nobody in the past, especially in certain companies, had thought that data should have been merged into a unified way. The first thing that when you start, you hire a couple of people, they face this huge problem, and some part of the problem is engineering. They might not be skilled. The other part of the problem is that the owners of this data and the data infrastructures are like the people in the different parts of the organization. So there is really a management challenge there to pull all of them together. The other thing is often they are data scientists who they know how to do the algorithms, but they don't know how to do this part. And then if they solve this part of the problem, there's the next part, which is launching this stuff into production. And there are lots of problems. Some are technological because the production environment might not be amenable to experiment, come back. So that's technological, but there are also the business problems. Like if you're in a SaaS company, for example, the account manager of a certain thing doesn't like to test that, or it might be that you're not ready to have multiple experiments to be run.
When you're trying to do innovation in a company and you're trying to manage an innovation process, you have to provide resources to the team that they can access. You have to get them those resources. That's your job as a manager, to figure out how to get them those resources. And you have to shield them from the process that exists, the delivery process. You can't have project managers coming in and micromanaging the innovation tasks because these guys don't know how to manage innovation. They know how to manage delivery. You can't have the fry cook telling the chef how to make the food. But the chef, if you're a chef, you do have to know, look, we have a fryer and we have a microwave. We don't have a fancy oven. Even the creative person has to have an environment where they can work in and they understand what tools they can use and what tools they can't. It's not just open season on anything. You have to ask yourself, when you put something into production, what is the smallest thing I can put into production? So I'll give you a good example. I work with a lot of clients trying to do this. Especially in IT departments love having automated deployment systems. They love Jenkins. They love Chef. They love Kubernetes. They love this stuff. You're not going to build an AI solution and have it be auto-deployed in your environment. You're not going to check it in the Chef and have it, or GitHub, and have it auto-checked out and deployed. That's not going to happen out of the box. And if you try to do that, it's going to take you 9 months to figure it out, maybe a year. What do you want to do? You want to get the data out of your database and put it somewhere. So you want to stuff it to a bucket on Amazon or a flat file. And maybe that process needs to be automated in the production environment. But really what you want to do is you want to spool up a development database or a replica, get the data out of there. And you're probably going to run a massive join on your database. So if you run a massive join in your production database, chances are you're going to cause a production outage. So you've got to get all the data out of the database and put it somewhere. A lot of people have been putting it into Hadoop. That's even worse because now you got to get it out of Hadoop. But you got to get it out. You got to get the data. And that's just something you as a manager, you have to figure out how you're going to do that in a way that doesn't disrupt your production environment and doesn't cause a production outage. Look, I worked with companies. I worked with the largest Hadoop cluster in the world. And the client was able to give us in production one column of data from the largest Hadoop deployment in the world. And then someone else, the other machine learning person in the company goes, well, why doesn't your model work so well? I go, you gave us one column of data. What? Give us more data. You gotta figure this out as a company. And this is your job as the manager. Even if you hire someone, they can't figure this out. You're not going to hire someone and they're not going to. So this is a challenge. Once you solve that, then you've got to put something in production. Now, what I would usually recommend is a microservice. What is a microservice? It's 5 lines of code. Make a request. Here's an ID. Give me some recommended IDs. A recommender system. Here's what we're looking at. Give me some recommendations. Search. Here's a search query. Give me things that people want. Keep a very simple API. One API. Try to get that into production. And in between the data, which you have to get out, and you put the flat file somewhere, or Hadoop or S3, or maybe in Spark, and your Flask API, your microservice, in between is the model building. Isolate that. Set up an environment where your data scientists can build their models, can install TensorFlow release candidate 2.0, which needs 2 versions of the NVIDIA drivers on a machine on Amazon. Isolate that. So the model building occurs. The data lake is created by the production environment. It touches it. The microservice touches the production environment. And in between is the AI, and that's not part of production. And then eventually you can integrate it. If you do that and you set it up that way, then you can create all these different models, deploy them into production and test them without having to go through the whole Jenkins pipeline or the whole Chef pipeline. That's what I recommend.
So basically, the idea here is the following. The problem that we discussed is that data are not accessible practically in the organizations. And then the second problem is that when you deliver these solutions in productions, there are a bunch of other integration problems. What Charles is suggesting is make things simple. Make a clone of all the data in an environment that you control so that you do not have to deal with the politics, the risk, and whatever. So you just have a clone of all the data.
And it doesn't have to be the latest data.
Correct.
Design a solution where you don't need live data.
So you don't basically need a real-time synchronization and application. So make a so-called simple system that dumps all the data. Then take your AI and make it live in a system that is of its own so that you can operate and do everything. And then basically have your AI to give recommendations to your existing platform. This way, it's a form of basically bypassing the problem so that you can experiment for a while until you settle on not only on a technical solution, but I would say until everybody else realizes that this thing is working, so that everybody's clear. Oh, now I see it. If it is a startup, it's technically complicated, but if it is a large company, I've been in engineering department with 500, 1,000 people.
Yes.
Just one division. You had to get all these people on board.
Yes.
From the top to the bottom. It's so easy.
If you try to build it end to end in the production pipeline, it will take you years. You have to have an isolated environment where you can manage the change yourself. Look, AI is bespoke technology. It's greenfield. It's changing all the time. We just upgraded. One of my clients just went from Ubuntu 12 to 16. The latest AI machines are running Ubuntu 18. You're working in something that's greenfield, and that every 6 months there's brand new technology that you have to use. When you do change management, there are things that can be automated because they don't change. Things that don't change a lot can be automated. Things that are changing all the time have to be isolated because you have to manage the change manually. You have to think of a systems level. I'm going to have to get the data out, and it's very hard. Look, a lot of companies for the past 2 or 3 years, all they've been doing is doing Hadoop. What has been the benefit of Hadoop? I worked on Hadoop-like systems in the 90s. I looked at Hadoop when I was at BlackRock 10 years ago, and I'm like, This thing is never going to do what you think it's going to do. We did this. We did this at the Supercomputing Center when in 1995 we had a 50 node cluster with a 3.5 gigabit ATM switch. The switch was $2 million. Each node was $50,000. That's larger than most Hadoop deployments today. That was in 1995. The benefit of Hadoop has been everyone's got their data out of the silos and they've put it into Hadoop. So it's all in one place. The challenge is nobody knows what's there. We're in California. We've got California CCPA coming up. It's the California version of GDPR. You're going to have to manage your data. The idea that you can just have data anywhere and anyone can access it and you can sell it, do whatever you want, those days are over. If you don't have a CCPA solution, compliance, you got a real problem. So you think that this is an issue. So you've got to manage your data properly. And the government's just coming in and telling you, well, you're going to have to. And they don't care how much it costs because it's a regulatory issue now. So if you're doing things like personalized learning or personalized recommendations, you have access to individual profiles in California, look, you're going to have to do something. But from a management perspective, yes, you want to isolate change. So you're not trying to jam this thing into your production deployment environments in an end-to-end way that 3 months from now is going to have to be changed again.
This is certainly a conversation that would take a long time, going into all the details. And I would like to move a little bit a step up. And I'm really thinking of a company that I worked with in the past that was a clear example of a tech company that have an interesting technology that could be magnified a lot in terms of benefits to the customer by artificial intelligence. But they were not born as an artificial intelligence company. They were not an AI first, as they say it today. So if they've done the first project, let's say that they have done something that is a recommender, if it is a website type of business, but it could be also, if it is a communication business, to me, it could be some dynamic dashboards that says how the communication is going and so on. Now they sort of, they've gone to the restaurant, they've taken the appetizer, they say, I like this thing. I like it. So now they start to think, but how do I scale it? Because now as a manager, I've seen that one, I can build better products. So, but I need to, now start thinking how different products. And then in my operations, both sides of my operations can be the logistics, it can be even the marketing operations, so on. This stuff can be interesting. So now I start to think, I really want to bring this technology in my company. I want to go from the first deployment to something that can be leveraged more. So what they should do a project by project approach, or they should create a central infrastructure and then have this central infrastructure to care about all the projects. What is the right recipe? Maybe it's another one.
Well, look, if you've had a successful project in the company and you're trying to grow an innovation team or an AI team, you've got to figure out what the resources are you're going to need to begin expanding. One of the challenges you may find is that when you claim that you're doing AI, and it turns out you really didn't do AI at all you did was linear regression, and that worked well. And you did some simple solution that you convinced people you got a business win, and now you're going to go off and try to do something more sophisticated. Well, you still have the leadership issue. You can't do linear regression and then hire a bunch of AI PhDs and expect them to fit in. So you're going to have to bring in, you're trying to win the business so that you can begin building resources and growing. You're going to have to create a team that can work together and do this. A lot of companies, there's sort of two approaches. You can create an isolated team, or you can bring in AI engineers and data scientists and pair them with regular engineers.
So very good. As our time comes to an end, I want to go back into your science on demand background. What important problem in AI do you think it's going to be solved at the industrial level in the next 3 to 5 years?
Well, I can tell you what I'm working on. So I am also, in addition to my consulting work, I fund and do some research with UC Berkeley on theoretical foundations of AI. One of the challenges that exists right now is that nobody knows why these systems work. Why do they work? And if you look at how academics think about things, I think Jeremy Howard had the greatest statement, 90% of all AI research is useless because it's just academic stuff, people getting papers and making students. And so it's good to create students and train them. But in terms of real research, You got to know why this stuff works. And the reason is because you don't know if you don't know why something works, you don't know why it fails. And you don't know when it fails. If you build a bridge, you can't test the bridge by driving cars over it and seeing if it falls down. And that's how people test AI systems now. They build a system and they test it and they test it and they test it and they try to see if it fails. And when it fails, they have to then try to fix it. And they don't know how to fix it. That's the biggest problem in these systems. You put something into production, and you better realize if you're doing AI, don't put something into production that depends on live data that can fail. You're not building a self-driving car because you might kill someone. You cannot build man-critical systems with something you don't understand because you don't understand what's going to fail. So from a business perspective, build low-risk systems so you can get going. Don't think that, but from a research perspective, people want to build systems that detect disease, that fly airplanes, that drive self-driving cars. These are man-critical systems. You have to know why this stuff works. And so we're probing the foundations of AI to try to understand why do these things even work? And if you can understand that better, you can do things like we have a tool called Weight Watcher. And what it does is it analyzes a neural network without looking at the training data. But we can analyze the robustness of a neural network without looking at data. And I've spent 3 hours arguing with my academic collaborators why this is important. In academics, you get a training set, you train a neural network, you test it, you publish, you have a metric. In the real world, you don't know what data you need. And the data sets are changing all the time. So when you do you try to analyze a solution, you've got to be able to analyze it independent of the data that you gave it. In other words, you can't drive cars over the bridge to test the bridge. You got to know why it's stable on its own. So these are fundamental problems in taking networks and fine-tuning them. How do you know if I take a network and I add data to it, how much data should I add? If I fine-tune a network, how much data do I need? If the data is corrupted, how do I know if the data has been corrupted or not? This stability and robustness analysis, why these things work, can you build systems that satisfy some kind of, that are reliable? How can you build? So this is the main problem with AI now, is that it's not reliable. And that's the biggest challenge, is making reliable systems. And I think that's where the real, when you look at what people are doing in industry, it's all, we're just building chips that are faster. We take the AI, we put in the chip, Qualcomm makes a new chip, NVIDIA makes a new chip, TensorFlow, RT inference. They're making it faster. They're thinking about how to make it faster, how to compress it, but nobody's thinking really hard about why it works and how to make them reliable. And that, I think, is the most important question.
One of the problems that are there with this unpredictability of when machine learning fails is due to the fact that we are using these learning systems like deep learning that, first of all, model only one element of the human cognition and the human intelligence, which is the learning by examples, which is only one part of human intelligence. And second is the fact that they do it really not understanding the context, but really building these features automatically. So it's a different type of cognition with respect to the human being. So for some people, that limitation is intrinsic. Like there is not really we need something new to solve the limitation. Now, do you think that this research you're doing in collaboration with Berkeley, maybe there's going to be other people around the world, is likely to yield results to solve this type of issue in the next 3 to 5 years? Because a lot of people believe that there is a connection between the problem that you are discussing about and the problem of general artificial intelligence.
Academics is, by its very nature, very close-minded. You would think that academics are open-minded but they don't. They're very close-minded because most of the work done in academics are people, you go, you do a postdoc, you do some work, you get a faculty position. In your early part of your career, you do something useful, and then you stop doing things that are useful and you manage students. So all the work is done by students. Students are not going to ask hard, deep, probing, conceptual questions. They don't do it. They're students. They don't have the ability. They're not dumb. They haven't been in the field long enough. And industry isn't going to do it because industry cares about making products. So most of industrial AI research is just making, cheaper, faster, better. So is it going to happen in 2 to 3 years? Probably not. Because, I mean, it's taken Michael and I 3 years working on our own in total isolation with not outside of the academic community by ourselves to do this. The innovation has to come from people who are dedicated to science, who have the freedom and the funding to work on deep conceptual problems. I mean, it could take 20 years to figure out why these systems work. And to really understand it's really, people right now are leveraging technology that was invented effectively in the early 90s. That's where this stuff comes from. That backprop, neural networks, backprop, convolutional nets, these are things that come from the early 90s. Modern advances, things like attention networks and transformers, yes, these are technical advances in the field, but they're not foundational advances. Large foundational advances have been occurring. This is so research goes very slowly. You know, there are only a few people in the academic world who are, who have tenured positions and have the wherewithal to do this kind of look at the work going on in Google DeepMind right now in protein folding. I don't know if you've seen this. We've solved the protein folding problem using AI, right? That's my advisor's work. He worked on protein folding for 20 years. He's still working on it. They hired his postdoc, John Jumper. John went there, showed him what they've been doing at University of Chicago. They plugged it into their deep learning systems and they made a huge advance. Okay, it's a big advance, but it's not like Google DeepMind was doing protein folding for 20 years. They hired someone to do it. They acquired the technology. They acquired it, and now they're going off and claiming that AI solves the protein folding problem. No. Carl's been thinking about this for 20 years, and he's at a place like University of Chicago where you can do that kind of work.
I think a very long conversation on the diffusion of innovations and the role of these large tech giants that have access to infrastructures and data. It's a very long conversation. I think for today, I hope that our audience has enjoyed having Charles here as much as I did. It's been so interesting to listen to him. If you have additional questions, please comment below wherever you find this video, on LinkedIn, on YouTube, or on Facebook. And if you have other questions, suggestions about other episodes, please reach out to me. And for the time being, Charles, it's been a great pleasure having you here. And thank you so much.
Hey, thank you. Thank you.